Okay, today we start with the example of compiler project. We start with this example. We'll explain breakdown structure. So it is a part of it's a technique part of scheduling, right? So now, so so whenever you wanted to develop any sort of compiler, so right. So now majorly we categorize these are the five important activities first. Okay, so one is requirement. First you need to gather the requirements related to the compiler, right? And then you need to come up with the design and then coding and then testing, and at the same time you need to produce the manual or the written parts. Okay, so now again you can see, so the activity. Okay, so the major activity now you can see, so that can be again that coding. Okay, so the code activity can further be you know subdivided. Okay, like you wanted to develop a lexer, you wanted to develop a parser for the compiler, you wanted to develop the code for code generation, right? So those sort of things, right, can be the sub modules of that particular code, right? So this way the large module structure is actually getting divided into smaller units. Okay, now, decomposition of the activities is carried out until any of the following is satisfied. So, I mean, you keep dividing or decomposing those activities to a level where you find the leaf level, sub activities or the tasks. Okay, so usually they will take only approximately 2 to 3 weeks to develop, right? So hidden complexities are exposed. So when you going through dividing the large activities into smaller activities, usually, so something if not done as part of a particular activity, so that can be further, you know, you know, it will reveal all its complexities. Okay, so that can be exposed. Okay, so that the job to be done is understood and can be assigned to a unit of work to one of the developers, right? So now like that particular leaf level sub activity can be assigned to a developer, right? So opportunities for reuse of existing software components is identified. Now you can think of like this way also, like you reaching to a leaf level sub activity which can be that which can be reused. That means maybe that can be, you can think of a smaller component, okay, which may be readily available in the market, that can be used in your project, or today you developed as part of your project can be reused by some other software also, because that is the smallest unit of work. Okay, so let's say for example it is something like this, the smallest unit that you have to develop as part of your project is sorting 10 numbers, right, or sorting 100 numbers, right? So let's say today you have developed a algorithm for sorting all of those numbers. Okay, now this sorting sub activity, now it can be today if you develop part of your project, maybe in other project, maybe that if that component or the sub activity if it is required, so then now you can reuse there also, right? So this way. Okay, so that means you will have to decompose the large activities into smaller activities which can be developed, which can be or which can be said as a unit of work. Okay, and that is what assigned to a developer. Now breaking down tasks to two course levels versus two fine levels. Okay, so it is necessary to break down large activities into many smaller tasks because smaller tasks allow milestones to be placed at shorter distances. So one best one advantages of this, going to two coerce level, I mean two fine level from the coerce level, is that so you can have the milestones placed at very shorter distances. Okay, so that means, as I told you, each and every task probably requires 2 to 3 weeks. That means, so after 2 to 3 weeks you can check whether you have whether you have completed that particular task or not, right? That means, so every 2 weeks you will be able to see whether you are reaching your milestones or not. Okay, if you're not reaching, then you need to take some corrective actions, right? But if you have a milestones kept like, after 6 months, okay, so after end of the 6 months, you will be coming to know that something is going wrong. Then what will happen? So you need to make so much of rework, and you need to going back to you have to retrospect all of the 6 years, right? So I mean, so you have to introspect all of the 6 years, right? So as to find out where that mistake was, and then taking an action. Maybe you will be taking that action, but it is already too late. Okay, so you can think of like this. So that means, yeah, using this thing, so you will be actually going to set the milestones, um, you know, uh, 1 or 2 weeks or 2 or 3 weeks, right? So this allows close monitoring of the project. Corrective actions can be initiated as soon as the problems are noticed, right? So however, very subdivision means that a disproportionate amount of time must be spent on preparing and revising um, various charts, right? So one problem with this mechanism is, so now you see, so because you are having many more such sub activities, right? So now, um, so what will happen? Usually, maybe you are not going to, let's say, for example, one is 2 weeks, one takes 2 weeks, the other one takes 3 weeks, or the other one takes 1.5 week. Okay, one activity. Now you will have disproportionate division. Okay, of these, so then in that case, what will happen? So usually it will be very much difficult for us to revise and prepare those charts again and again, right? So let's say one activity is finished, then what do? You will be updating that particular chart, right? So like that. So that means if you have very smaller, subdivisions, as well as if they are very disproportionate, then in that case, so revising takes too much of time. Okay, that's only the one difficulty. That means it is a very tedious task. So breaking down tasks to two course level, I mean. Queries levels versus the two fine levels, right? So while breaking down an activity into smaller tasks, a manager often has to make some hard decisions. Okay, so when you are going to divide these all, large activity into further smaller tasks, so usually, so manager has to make a decision, right? So because he need to first of all find out what are the subdivisions of that particular smaller activity. Okay, I mean of that particular activity. So here major role, in this context, so manager plays a very major role, right? If an activity is broken down into large number of very small sub activities, okay, so these can be distributed to larger number of developers, right? So this is what you can understand, right? So if you have large number of sub activities, so usually these all sub activities will be assigned to large number of developers, right? So then if the task ordering, now that is fine. So if you have a large activity, now that large activity is actually divided into large number of sub activities, and these sub activities are assigned to different developer. That is fine. But Now then you need some sort of ordering also, right? That means so it's not that all of those sub activities will be will be carried out very independently, right? And so there must be some sort of dependencies also, right? So if the task ordering permits that solution to these can be carried out independently, parallel, and it becomes possible to develop the product faster with the help of additional manpower, of course. Okay, so now what you do here is, so if you follow some sort of task ordering, okay, like as I told you, so you have a large number of tasks, right? So you can say something like this, right? So let's say you have 1,000 number of tasks, so you will be saying 1 to 100 tasks, okay, should have to be done maybe within 1 month. The rest may be done in another month. You can think of, right? As a result, what will happen? Certain activities you can carry out parallelly, right? And certain activities will be dependent on the other activities, right? Unless or until those activities are finished, you are not allowed to go into the other activities, right? Now, so sometimes what you can do is, so let's say, as I told you, so if certain things need to be carried out parallelly, so in that case, maybe, you need more additional manpower, right? Because you wanted to carry out, parallelly many things, right? So let's say you want only 1,000 people need to be work. Now they wanted, if you want that, 1,000 people will work towards the project. So now previously it was not thought of like you will be carrying out many parallel activities. So now suddenly if you decide that you wanted to run many of the activities parallelly, so in that case maybe you need more number of employees at that particular point of time. Okay, so therefore, to be able to complete the project in the least amount of time, the manager needs to break large tasks into smaller ones, expecting to find more parallelism. Okay, so usually, so it's a good way that you always try to find some parallelism, but as I told you before also, so you can have certain number of parallelism within the activities, that is fine, but 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 there are certain activities so which cannot be carried out parallelly, right? So however, it is not useful to subdivide tasks into units which take less than a week or two to execute, right? So usually, so we divide the large task into the smaller tasks, right? And those tasks can be solved within, I mean, maybe within 2 weeks or 3 weeks, right? But less than 2 weeks, so usually it's not suggested. Okay, it is not suggested, right? So many managers believe an aggressive schedule motivates the engineers to do a better and faster job. Okay, so it's a human being, right? So if you would be managing uh, certain activities in your organization, so you always want, like, if I give very aggressive time schedule, so that people will work very faster and better, because they will be completely stick to the work, they will not be deviated from the work. So this is what we believe. Now that is fine, but certainly we have seen now as per some experiments, so that also shown that some unrealistic aggressive schedules can cause engineers to compromise on some intangible quality aspects. That means, so if you assign unrealistic time schedules or the aggressive time schedules, right? So in that case, you are not going to get quality output. Okay, so that is what say. So that means if I say, let's say if I say something like this, so if I give you an assignment, right, and if I ask you to give me that particular assignment within 1 day, probably you will not be going to give me the I mean you might not have, you will not be able to give me the good solution, right, to the problem, right? But maybe, if I give you 2 or 3 days, maybe you will be going to give that. So that means, so you need to think of, right? So that's, I mean, you should be always giving realistic schedules, okay? So also cause schedule delay. So if you are giving any unrealistic, schedules, in that case, so what will happen ultimately? So everything will be delayed because you will not be coming up with the, you know, uh, intangible quality things, right? I mean, as a result, um, you will not be, no, things will be delayed. A good way to achieve accuracy, so let people set their own schedule. So, other way, we think that better, we give the freedom to the developers, so they should set their own schedules. That would be better because they are the one who is going to develop that particular task, right? So uh, so usually, for a large size task, so usually it will take too long time, right? So usually the managers try to break that particular large task into smaller ones and try to find some parallelism, right? uh, right, if we have, like, small size tasks, as I told you before also, like, so that means we are putting the milestones, at a very distance of 2 weeks, right? So now, as a result, you will be able to properly monitor the task. So now we will consider. Let's say we discuss. We'll take the example of a management information system. Let's say you are going to develop a management information system, right? So now that particular, so now then, so the project manager, he will identify, certain main development activities. So usually, mostly, so yeah, so part of any project, so usually you have, these are all the very important activities, right? Like the requirement specification, design, code, and then testing, and then finally the user manual, right? So these are the very important activities, right? So these are the main activities that you can think of, right? So, and after that, what you do is, now this design part, now that can again further divided into sub activities. You can think of something like this. So you need to have a database design, okay, part, or you need to have a graphical user interface design part, okay? So now that can be again two different sub activities. So GUI and database, so those design can be done parallelly, okay? Right. Similarly, now for the coding also, so you can carry out the coding parallelly, right? So few developers, maybe the coders may be developing the database part, few developers may be, working towards the graphical user interface part. So developing codes for the graphical user interface part, right? So this way you will be actually breaking the large activity into small units, right? So now if you still think that, as part of database also, you need to think, like, let's say, for example, so maybe your application has a scope to include so many databases. So maybe one may be, Oracle, the other may be Sybase, the other may be any other no database system that you can adopt, right? So like this, similarly, you can think of, right? Then you further divide that particular activity to sub activities. So here in this case, you will have the rectangle ones, so which will be, which represents the activity, and the arrows are the ones, telling you that it is a sub activity of that particular activity, right? Now, so we are going to use the other technique here is the activity networks. As I told you before, there are two techniques. So one is work breakdown, work breakdown in a structure. The second one is activity networks, right? So now an activity network shows the different activities making up a project and their estimated durations and their interdependencies, right? So now as part of an activity diagram, what you will see, we will see what are the different activities that will be carried out part of a project, okay, and associated durations. That means each and every activity takes some durations to complete that particular activity. And now, as I said you, so they follow some sort of ordering, right? So that means unless the first activity is finished, maybe you cannot start the second activity. Or if you have three activities, in that case, the first activity, after a completion of the first activity, now you can carry out two parallel activities like maybe the activity 2 and 3. Okay, so now there is a interdependency, right? That means as I said, you activity 2 and 3, they are parallelly they can be carried out, they can be executed, or they can be carried out parallelly because they do not have much of dependencies, right? But now 2 and 1 has a dependency. Unless or until 1 is finished, you are not allowed to start the second activity. Similarly, unless or until the first activity is finished, completed, so you are not allowed to go into the third activity, right? So two equivalent representations for activity networks are possible. And usually we follow activity on node or activity on edge. These are the two representations. Okay, so there is a very slight difference, right? So you can think of something like this. Okay, so when you say activity on node, so mostly you can see, so each and every node will have the durations. Okay, I mean how long it is going to I mean how much time required to finish that particular activity, right? And so that is exactly the milestone. Okay, so those things are represented by the circle. Okay, so you can think of here. So now once the work breakdown structure can be refined into an activity network representation where you will have network of boxes and arrows. So once you understood, I mean, if you have understood, work breakdown structure, now that will be converted into an activity diagram or activity network representation. Usually, part of activity network, so you will have some boxes, or sometimes, sometimes boxes, or sometimes that can be represented by a circle also. Okay, we'll see through an example, then you will be able to understand, right? And then there are some arrows. Okay, going from one box to the other box. Okay, so that means there are certain number of activities flowing, not flowing. That means after that particular activity is finished, now then the second activity can be allowed to start. This is what exactly going to represent, and each and every activity takes how much time to finish that particular task, okay, or the activity. So shows the different tasks making up a project, representing ordering among the tasks. That means you will be going to see some sort of ordering among those tasks, right? So it is important to realize that developing the WBS and activity diagram requires a thorough understanding of task involved, right? So that means in order to come up with these two diagrams, like that work breakdown structure or the activity network, you need to have a thorough understanding of these all different tasks involved in the project, right? So then only you will be able to come up with this. So each activity is represented by a rectangular, or some use circular. That is what I said you. And the duration of the activity is shown alongside each activity in the node. So between that particular node, how long time it will take, okay, to complete or finish that particular activity. So that is what provided is part of the node, or the rectangle, within the rectangle or within the circle. Okay, so usually that particular circle represent an activity. Okay, So the inter-task dependencies are showing are shown using directional edges. Okay, so usually through directed arcs. So we will represent that which particular task is dependent on which other task. Okay, so that can be shown through a arrow. Okay. So that is what exactly part of a activity on node. Now the other one is a activity on edge. So here what will happen? Here is also the same thing, but only thing that whatever the task that you have, that will be associated with the edges. That means, so there in the activity on node, what you do inside that particular node, you will mention, I mean, the name of the activity as well as how much time it is going to take. Okay, that means milestone. So now here what will happen? So now one task is connected to other task through a edge. Now that edge will represent here actually the task, whatever the task that will be, right? So everything will be mentioned on the over the edge. Okay, that is only the difference. Okay, so you can see, you can understand, right? So something like you have a graph with weights, okay, so there what will happen, you have certain number of vertices and edges, and the over the edges you are giving some cost, right? Similarly here, so each and every edge represents certain number of tasks that are associated. Okay, so that will be represented. Edges are also annotated with the task duration. So there also part of the about the edge only, you will be mentioning the task duration also, how much time it is going to take. So the nodes in the graph represent project milestones. So here, so each and every node will tell you that is what the milestone. Okay, so how much, I mean, you can understand, right? So activity A, B, C. So I mean, once you reach to the activity C, that means you have achieved some milestone, right? So that is what. So activity networks were originally represented using activity on edge. Okay, so initially people have used activity on edges, but however later activity on node has become popular since the representation is easier to understand and revise. It is only the uh, it makes us very easy to understand. That's only, that is the reason why activity on node is much more popular. Now you can understand, right? So before we going to before we come to a representation of activity network, so first thing that you need to know is, so as part of this MIS management information system project, so now, so first thing is that the manager has to determine the different number of tasks and how much time, I mean, each and every task will take to complete or finish, and which are the tasks dependent on which other tasks. Okay, that is what need to be mentioned. Okay, so now, so usually your project manager will determine all these things, right? So let's say there are tasks, okay, T1, T2, T3, T4, T5, T6, T7, right? So now, so one is that first task is a specification, requirement specification, and the second one is a design, third is a coding, and the fourth is a integrate and test, and then write user manual, right? Now, so as part of, we have seen in the previous diagram, the network, the activity network, when I was discussing about this WBS, I mean work breakdown structure. So we have seen that, right? So now the design part is further divided into two, right? Database design and GUI design, right? Similarly, coding database part and coding the GUI part, right? Now, so for each and every activity, so we have some durations. That means these activities will take this 15, maybe you can say it is in minutes, or it can be in hours, or it can be in weeks, or it can be in months, or it can be in years. Okay, so you can take any unit. Okay, so duration, when I say, right? So 15 days it may take, okay, or 45 days, 30 days, or 15 minutes, 45 minutes. So this way, okay, duration can be. Now you can see here. So the T2 task is dependent on T1. Okay, dependent on T1. That means unless or until T1 is finished, so you cannot go and start this T2 task. Okay. Now this T3 task is dependent on also T1 task. Okay. Similarly, now T4 task is dependent on T2. T5 is dependent on T3. Now T6 is dependent on T4 and T5. Unless or until this T4 and T5 are finished, so you are no way allowed to go into T6. Okay, this is what. So now similarly, so T7 is dependent on T1. So now this is what the dependencies are given, are identified by the project manager along with the duration, right? Once these are done, now we will going to design an activity network. Okay, from this. Now, so I told you, so usually we use activity on node mostly because it is easy to understand. So this is what. So each and every rectangle represent a milestone or it is a activity. Okay, it is activity, and this particular, I told you, specification will take 15 days or months or minutes, whatever may be, right? So similarly, now if this is the task 1, okay, so now there is a task 2. Okay, task 2, design of database, which will take 45 days. Okay, and it is completely dependent on T1 task. Now T2 is dependent on T1. Similarly, T3 is dependent on T1. That means design of CUI will be carried out only after the specification. Okay, design of GUI will be carried out only after the specification. Similarly, write user manual also, right? So now the activity 7 is also dependent on the activity 1. Okay, so this way you will be drawing set the activities, right now this design database, once this is finished, then only you can code that particular activity. Okay, similarly, once this design of GUI is done, then only you can code the GUI part, right? So now finally you can understand, right? So I mean, so you have what you say, so your arrow will represent the task ordering, right? That means how these activities are ordered. Okay, as well as it is going to tell you that each and every activity, how much duration it will take. Okay, so this way now you can draw the activity network. Okay, right now whatever the table that we have seen, so that is what exactly represented using an activity network. This is what I told you. So each and every rectangle will represent one activity. Okay, and their durations. This is what the activity network is. Now similarly, so you can have a activity network diagram for the compiler project also. So first you have the requirements, right? And then you have a design. Okay, after that you will be developing the code lexer, code parser, code code for code generator, right? So and then once all of these are coded, then only you can go to testing activity, right? Now so you can see here code lexer, code parser, code for code generator. Now these three activities can be parallelly executed. Okay, and similarly, so while you doing the designing and while you developing the coding, parallelly you are carrying out the creation of manual also, because you parallelly you creating the reports also, right? So like so these things, like if you using any Java programming language, right? So you can think of these days, so there are compilers for generating the comments or the manual from the code, right? So there is a Java doc, Java doc is the compiler through which you will be able to create the documentation, right? So like whatever the comments that you given as part of your code, now everything can be created as a report also. Once the code is compiled, so automatically the document is created, right? So now if you have compiled the code lecture part, so lecture part, so now you can generate your manual. That means, so I mean, while you doing the design, while you doing the coding activities. So you certainly creating the manuals parallelly. Okay, that is what through this activity diagram it represents, right? So certain things can be done manually, and certain activities are dependent on certain other activities, like coding activities completely dependent on the design activity. Now the design activity is completely dependent on the requirement. So similarly, your testing is also dependent on coding, right? So this way now you can represent any activity network, right? Any doubts so far, students?
No, sir.
No, sir.
Okay. Okay, so managers can estimate the time duration for the different tasks in several ways, right? So, one possibility is that, the managers empirically, assign some durations to each and every task, right, based upon their experience. Okay, so they will be saying that, coding this particular module or coding the, this particular piece of sub activity or design activity, so it will take these many 2 weeks or 3 weeks. So it's an empirically, the values are assigned empirically, the duration is assigned empirically. Now this however may not be such a good idea, because software developer often resent such unilateral decisions, right? So because we as a developer, right, so we usually do not try to follow whatever my manager says. If my manager says, mostly if he is going with a very aggressive schedule, like so now you, let's say, according to you as a developer, you may think that this particular module will take 3 weeks to complete, but maybe your manager will give you 2 weeks to complete. So then what will happen? So usually we don't like that particular manager sometimes, right? And also as a result, maybe sometimes you know will not give good outcome. So that is what. So that is the reason why. However, some managers prefer to estimate the time for various activities themselves, right? So that is what. So some managers allow allow the developers to decide what duration they want to complete that particular task. Okay, and some managers, so they assign some duration. So this is what, there are two ways by which you usually assign the duration of each and every task, right? So they believe that an aggressive schedule would motivate the developers to a better and faster job. But on the other hand, so we have already seen, right, some unrealistically aggressive schedules actually not going to give the better output. Okay, so that means as a result, sometimes there will be delays in the schedule, so which is not acceptable, right? So that's the reason why some managers allow the developers to estimate whatever the time they want. Okay, so that means whatever the time they want, it is not like that. So they will be actually, because they are also working, right? So they will also have some sort of experience, right? So they can also think of what would be the duration, okay, to finish that particular activity. So this approach can help to accurately estimate the task durations without creating undue schedule pressure, right? So now, if you are going through this sort of approach, probably going through activity diagram, and if you are following this schedule, probably we may not be end up with any schedule pressure. That means we'll be meeting all the deadlines appropriately. Now you have seen that particular activity network diagram, right? So now, so you can see there, so there are certain activities. Now you can start from a particular source activity, and then now you can go to a destination activity, right? That means so that is what exactly a path. So path is something, so if I say any path in the activity network, it is a any set of consecutive nodes and edges in the graph from starting node to the last node. Okay, so that is what exactly I have shown through. So you can think of like this, okay, as part of this, right? So specification to design and then to code and then to integrate and then finish. So this is one path, okay, this is one path, right? From specification to finish. So this is one path, okay. The other path may be specification, design of GUI, coding of GUI and integrate and then finish. Okay, that can be another path. And specification, write user manual and then finish. So that can be the third path, right? So usually a path in this particular graph is a set of consecutive nodes and edges. Okay, so this is what. Right. So now then we need to find something called as a critical path. Okay. So a critical path consists of a set of dependent tasks that need to be performed in a sequence and which together take the longest time to complete. Okay. So we will try to, a critical path means, so we try to identify a path. Okay. So in that path, okay, and if you going through that particular path, usually it will take the longest time to finish. I mean, the longest time to complete, right? Now you can see. So here in this graph, you see, so it is what? Now you can see if you going through this particular path, so probably it will take longest time. It will take longest time. Okay. And so these are the paths are not going to take longest. Now you can think of something like this. Okay, so now if you think of like this, okay, coming to finish, okay, from start node specification, which path will take the longest? Can anyone tell me? Can anyone here tell me which one will be the longest path? The upper one or the below one or the middle one? Upper one.
The upper one. Yes, sir.
Yeah, it is obvious, right? So that's the upper one will take more time. Okay, and we are interested here. Why the maximum time we are interested? The longest duration we are in. Why we are interested in the longest duration? Can
Sir,
anyone tell me?
it is the minimum time we required.
Yes, yes. So it is the minimum time required to complete the project. Okay, complete the project. It is not the, so to complete the project, this is the minimum time. Okay, so we are interested in this. That is the reason why we take this. Okay, the maximum time. Right. So a critical task is one with zero slack time. That means, so if there is a task, if it has any slack time, okay, so then that is, that is not called as a critical task. A critical task will have zero slack time. Okay, that means that task is no way going to wait for any other task. Right. Now you can think of something like this. Okay. So these are the tasks. If you see, let's say, if you see this, okay, now, if you see here, let's say code database, okay, coding the database. Now it has no slack time. Why it has no slack time? Can you tell me, anyone? I mean, it is not going to wait for any other activity to finish. Okay. Do you understand? So as part of your coding, what? There are two sub activities. One is code database, the other one is code GUI. Okay. Now code GUI will take less duration. Okay. And coding the database will take more time, right? Now, so out of these two activities, which one will be finished fast? Out of coding and code database and code GUI, which one will take? Which one will finish fast? Finish what?
Code GUI.
Code GUI will
Code
finish
GUI.
fast. Okay. And now what will happen? That means now code GUI part is finished, but it cannot start the integrated testing. Why it cannot start the integrated testing? Because unless or until code database and code GUI both are finished, this activity will not start. That means now this particular activity has a slack time. That means you can think of like this. Okay. अभी जैसा कि फॉर एग्जांपल राउरकेला में कोई एक ट्रेन है, ओके, उस वो ट्रेन का टाइमिंग दिया गया है 1 बजे उसको छोड़ना है, बट तो कुछ रीजन बहुत फास्ट आ गया और वो पहले आके पहुंच गया 12:30 में. तो व्हाट विल हैपन इफ इट हैज अराइव्ड before its time, what will happen? So it will wait for some time, right, till it reaches its scheduled time. Okay, उसके बाद ही उसको start करना है. That means so that particular train might have a slack time. Okay, कई बार हम बोलते हैं ना ये कुछ trains के लिए slack time दिया गया है, because maybe due to certain reason, this sort of, right. So those trains will so now you can think of, but your coding database, what will happen once the coding database is done, coding of the database is done, so you will be going to integrated testing, because by the time your code GUI is also completed, right, because of which so you will be going. That means this particular activity has no slack time. Okay, you can understand this way. So a path from start to finish node containing only critical tasks is a critical path. Now you understand. So now the other way you can define the critical path is, so as part of a critical path, whatever the activities that you will have, they are all critical tasks. That means they do not have any slack time. Okay, so then that particular path is called as a critical path. Okay, so that's the other way you can define this critical path. Okay, so when you identify the critical path, so that is the minimum time required to complete the project. Okay, so now it is computed by determining maximum of all paths from start to finish. Okay, so now you can understand this. Okay, so why we are interested in the minimum time? So minimum time here means it is the maximum of all types. Okay, so that is the minimum time required to complete the project. Okay, so now there are certain other terminologies. Okay, now earlier start. Okay, so earlier start means it is the time of the task that the maximum of all paths from the start to this particular task. Okay, so earliest start can be calculated like this. Okay, so whatever the task, wherever the task you wanted to see the earliest start. Okay, now it is the maximum of all paths from start to that particular task. It is not from start to the finish task. It is not that. Okay, it is the earliest time defined for each and every activity can be calculated like this. Okay, maximum of all paths from the start to that particular task. So that will be considered as the earliest start. Okay, and similarly you can have a latest start also. Okay, how latestly you can start your activity. Okay, so it is the difference between empty, that means the minimum time, and the maximum of all paths from this particular task to finish. Okay, so their earliest time is start to that particular task. Okay, now here maximum of all paths from this task to finish. Okay, and then difference between the minimum time. Okay, whatever you obtain there. Okay, so that is going to give you latest start. Okay, or you will be able to, if you do not understand now, you will be able to understand the other way also, right? Now similarly, so you can have earliest finish also. How earliest you can finish? Let's say you have for a particular task you wanted to calculate earliest finish. So earliest finish will be like this. So you have a earliest starting time. So you have a earliest start time. Now earliest start time plus the duration it will be going to take that particular task. Okay, that means it is the earliest finish of that particular task. Okay, So how earliest you are going to finish that particular task can be calculated by earliest start time, whatever you previously calculated, plus the duration it is that particular task is going to take. Okay, that is that EST. Okay. Similarly, you can calculate the latest finish also. Okay. So the latest time by which a task can finish without affecting the final completion time of the project. Okay. So how latest by latest time your task is going to finish, and which will not actually affect the completion time. Okay, that is what. And a task completing beyond its latest finish would cause a project delay. So whatever the if your task is completing after this latest finish time, then definitely there will be a chance of project delay. There will be a overall project delay. Now this can be calculated, so by you have a empty minimum time. That minimum time, from that particular minimum time you can subtract maximum of all paths from this particular task to finish. Okay, if you subtract this value, then you will be able to get the minimum. You will be able to get the latest finish time. Okay. So similarly, now the slack time can be calculated like this. Okay, so you can think of, if you have a latest start and you have a earlier start. Okay, then you can calculate the slack time for a particular task. For any particular task, you can calculate the slack time. So that is LS minus ES, or you can have, if you have a latest finish minus earliest finish, or you have a latest start minus earliest start. Okay, so that will be going to give you your slack time. Okay, now you can think of this. So we are actually going to calculate the critical path for that particular activity diagram. Okay, so you know that I have given you in the form of a table, where you know that there are T1, T2, something like this. Okay, we are actually so we are going to develop this activity diagram. So your requirement specification is the first T1 task, right? So requirement specification is the T1 task. How much duration I have given there for the specification requirements? I have given 15. Yes or no? I have given 15. Okay, duration, right? So now what will happen here? Earliest start is, so how earliest you start this activity? So you will be starting from the 0 only, right? So your earliest start is 0. Okay, and then how you calculate the earliest finish? So I told you, earliest start plus the duration that particular activity will take. That means 0 plus 15. So it is going to give you 15. So earliest finish time is 15. Okay. Now, so the earliest start time of the other activity will be the earliest finish time of this activity, previous activity. Okay, because just after this activity you are going into the design in database, right? That means you do not have any zero time between this, right? After completion of, that means earliest finish is 15. So that 15 will be the earliest start for design database. Similarly, so earliest start of design GUI is also 15. Okay, earliest start of write user manual is also 15. Okay, now so what is the earliest finish time? So it will be, why, how it is 60? Can anyone tell me how it is 60? Can anyone here can tell me how this earliest finish will be 60?
Is start time plus the duration of design data, that is 45 plus 15 is 60.
Right, true. Okay, so that means I told you, right? Earliest start means, earliest finish means earliest start plus duration, right? So that means 15 plus the duration takes this is 45. 45 plus 15, it is going to give you 60. Okay. Similarly here, so the duration for the design GUI is 30. So 15 plus 30, so it is going to give you 45. Okay. So for writing user manuals, we have given 60 duration. Now you can see 15 plus 60, it is 75. Okay. Now for this code database, now what will be the ES? So ES will be the EF of the previous task. Okay, dependent task. So here the dependent task is data, design database, right? 60. So 60 will be the ES for this activity. Similarly, 45 for the code GUI, right? Now for write user manual, what is the ES? It is the ES of yes. What is the ES? It is the EF of earliest finish of the requirement of the specification, right? That is the reason, right? 15, and the duration it takes is 60, so it will be 75. Similarly for the coding database, so it takes 100 not 5, so it is a 165. So similarly like this. Now coming to integrate and test. Okay, now what you need to do, so I told you, so it's a maximum of all paths till that particular task, right? So now here in this case you can see, so there are two activities. So now this particular integrate and test activity is dependent on two activities. Now what you need to do, so you need to take the maximum of these two. Okay, you need to take the maximum of these two. Which one is the maximum? 165 is the maximum. That is the earliest finish. Okay, so very earliest finish that you need to take. Okay, so that means very earliest finish, so it is a 165 maximum of these two. Okay, so then 165 you will be getting, right? Plus how much duration for integration testing, so it is going to take 120, right? So
120.
165, yeah, so 120 plus 165, it is going to give you 285. Okay, now here is also you can say, now the finish activity, so you need to take the maximum of two activities, right? Which one? So integrate testing and write user manual. So because it is dependent on these two activities, so maximum is 285, so earliest start is 285, and then earliest finish is 285. Why? Because the finish task is takes only 0 duration, right? So 285 plus 0, it is 285. So this is the way that you will be able to calculate now. So you will be able to calculate the what you say. Now you can see out of these, which one is the path actually taking. I mean, while you are going through, which one are the critical tasks. So you definitely see these are the critical tasks, the top ones, the okay, because it is always giving you maximum. Okay, it is always giving you maximum, right? At the design of database, it is the one who has the maximum value, right? 60, and it is the one when you coming to the code design, so 165, and when it is coming to integrate and user manual, out of these two parallel activities, right? So it is the one task which takes maximum time to finish. So now you can see that is the reason why the upper one will become the critical path. You can understand. Okay, so the critical path can be identified like this. Okay. Now similarly, now you can see, so let's say how you going to calculate LS and LF. Okay, latest start and latest finish. Okay, now you can see like this. Okay, so you have a latest start and latest finish of 285, right? Now your latest start of this particular activity will become the latest finish time of the latest finish time of this preceding activity will be the latest start of
Sir, data mining classes started.
what?
Sir, data mining extra classes started.
Yeah, just give me a minute. Yeah, we'll finish this and then we'll go into. Okay, so your latest start so will be like this. Okay, unless or until you can simply see here, right? So to latest start, whatever you have, that will be the latest finish time of the preceding task. Okay, right? So that is the reason why 285 whenever you have a latest start, so 285 will be the latest finish time. Okay, right? Now, so what you will be doing is you deduct, whatever the duration from 285, what is the duration? 120 it takes. So 285 minus 120, it is going to give you 165. Okay, so similarly for this, so write user manual. So 285 is the latest finish time. Okay, minus how much? So this takes 60 duration. So 285 minus 60, it is going to give you 225. Okay, now similarly you go on like this. Okay, so latest finish of core database is how much? 165. Similarly, latest finish of code GUI 165, because its latest start is 165. Okay, it's success, succeeding, task takes 165 ls. Okay, now, so similarly you go on deducting, right? So 105 minus 165 minus 105 is going to give you 60. Okay, similarly 165 minus 40, so it is going to give you 45, it is give you 120. So similarly you go on. Now you come to this. Okay, so now you come to design database, design GUI, and write user manual. In this case, now you have three different there are three different tasks which are dependent on the task one. Now in this case, what would be the latest finish for this particular task? So here it is, the latest finish is 15. Why it is 15? Because we are going to take the minimum of all these three. Okay, so minimum of all these three activities. So what is the minimum of these values? So the for the latest start, here you have database design database of latest start for the design database is 15. So latest start for design GUI is 90, and the latest start for write user manual is 225, right? So you will have to take the minimum of these three. Okay, that will be the latest finish time for this. Okay, and your latest start is always 0, right? So this way you can, so when you are going through when you are calculating earliest start and earliest finish, in that case, so whenever you have two different tasks on which a particular task is dependent, in that case you will have to take the maximum value, whereas in case of latest start and latest finish time, in that case you will have to take the minimum. Okay, so that is what the difference. You can go through the slides again, you go through the definitions again, you calculate it, and you will be able to see, right? So now, so from this, once you got the ls, okay, and you have es, so then you can easily calculate slack time for each and every task, right? The slack time will be what? Es minus ls, or ef minus ls, lf minus what is that you have seen in the past? So ls minus es, as well as lf minus ef. Okay, this way you can calculate the slack time for each and every task, right? So this is what all about so we'll continue about this part in the next lecture, as well as we will go into the probabilistic nature of this part, and then we'll end. So now I stop the lecture. Any doubts so far?
No, sir.
Sir,
Yes.
sir, in the latest start and latest finished calculation, basically we are moving first in the critical path direction and then recalculating by subtracting.
No,
the time.
not like that. Not like that. You see, you started with the finished task. I have given you a way to calculate, but you apply whatever the quickest way I asked given you to calculate these all values, right? So you go through the definitions of ls and lf, right? So that is one I say. So you started with the finish. So you know this. This is the 285 is the earliest start as well as earliest finish, as you calculated in the previous case, right? And then you go by backward direction you are going, and then you can calculate, like this, if it is a ls of a particular finished task, can be the lf for its previous task. Okay, because that is the something it very latestly finished, and that is the latestly started also, right? So now and then you deduct the duration from that. So you keep on going back to from there. So in the previous diagram, we going from this to end. Now when you are calculating ES and EF, so you are going from start to end. Now here you can go from end to start. Okay, that's only. So while going from there to there, so usually we have taken the maximum wherever you have two dependent ones, and while going the backward direction, whenever uh, you know there are multiple tasks which are dependent on a particular task. So in that case, you will have to go with the minimum. That is only the thing. So ultimately, you need to find out the critical path also. You can calculate here also. So each and every task will be a critical task. When you find that over that particular path, the nodes will also become a critical task. Is it clear?
Yes, sir.
Okay.